I'm Xiaofei Zhang, the Cassava breeder and CIAT. So today I'm going to report the activities and achievements in the Objective 2, breeding and selection, in the project of establishing sustainable solutions to cassava diseases in mainland Southeast Asia. So in this project for Objective 2, so we mainly focus on capacity building and also enhance the collaboration with national programs, work with national program to identify and incorporating the norm disease resistance to national breeding program populations. So the CMD was reported in 2015, and since then, CIAT has been working closely with national program to introduce new CMD resistant germplasm. So in general, there are three source populations. So the first one on the top is the seeds introduced from Hawaii. So in the next-gen project, CIAT and IATA will work together, provide alien germplasm to Hawaii, and they made cross seeds, and they have seeds available for Southeast Asia, and the seeds were imported in 2020. On the other hand, at CIAT, about 20 years ago, CIAT has developed a population course with CMD resistant clones with alien CIAT material. So the population was also introduced to Southeast Asia. And the third source population is from IATA. So they kindly provide 5 top CMD resistant clones. And so now in this project, we may evaluate these populations to identify the best material and hope we can release the first generation of CMD resistant variety in Southeast Asia. So in terms of breeding activities, it's mainly occurred in Vietnam, since there is a strong breeding program, and we also work closely with Thailand breeding program. So in Vietnam, so here it shows a trial testing network. So the main focus is the south part of Vietnam, so where the CMD pressure is high, and also the cassava production is mainly focusing in this region. So in Vietnam, we mainly work closely with 2 national programs. AGI is in number 7, located in Hanoi, and Hang Lok Agricultural Research Center, located in Dong Nai. So it's really the major CMD region. And here I want to show you the timeline of our activities. So first, we introduce the CMD resistant material from CIAT and IATA. So this mainly was done by AGI because they have a very strong team in tissue culture. And Hang Lok introduced the seeds from Hawaii. And also Hang Lok evaluated the collection from a farmer's field in Vietnam. There are about 142 clones. So they have been evaluated this material in hotspot. We found some new CMD resistant material. I'm going to talk about them later. And then the next year we plant them in the introduced material in the hotspot region is in tanning, and we find the resistant material. Then we put them in multiplication trial and also in the advanced yield trial, and to understand their agronomic performance. And then in 2021 to 2022, we really have regional yield trials in 6 locations. And start from this year, AGI and Hang Lok, they really have demonstration trials in different provinces and in large trial site. So, and after we confirmed the resistance and identified the best CMD resistant material, we shared this material with Laos and Cambodia and Thailand. So we are going to establish a regional yield trial and really try to understand the TB Also, this material either from AGI or from CIAT. Again, AGI has a pretty strong tissue culture lab, so this is a very good advantage there. So after we identify the CMD resistant material and know which is the best ones, so we established the cross nursery in 2020, and we harvested the seeds and planted the seedling trial in 2021. So now we are harvesting the seedling trial and advance the material to single row trial. So in the seedling trial, we made selection based on plant type and also using CMD2 markers. In this project, we validate the CMD2 marker. The CMD2 is a major dominant CMD resistant genes. There is a marker, linked marker with these genes. We validated this marker and now implement these markers in breeding. Also, I want to mention, so we introduced the flower inducing technology to Vietnam, and also Thailand is also using this red light system to induce early flower for Cassava. And the next I want to talk a little bit about the breeding program improvement or capacity building. So here is mainly focused on the genetic gain, the four major components. So first, genetic diversity. We talk about the CMD resistant material we introduced to Southeast Asia, and also the flower inducing technology. So that really help us be able to make crosses for the erect for the clones with erect plant type, and also we focus on erect cross with elite cross with elite progenitors. In terms of duration of selection cycle, so this is the breeding scheme. So we decided to cycle back the material after the single row trial, evaluated in 2 locations. So this is about 3 years, compared with conventional one is usually 4 or 5 years. And for selection intensity, I would like to mention the markers again. So we validated the marker and now using it in the year 1 selections. And for accuracy, we started using Cassava base. All the regional trials uploaded in Cassava base. And also we test material in multiple environments, especially for the single row trial we started at 2 locations. And we consistently use at least 4 checks and also using blob to calculate to evaluate to see the performance of the breeding material, and also using row column design, we can adjust the field variation. So in the next several slides, I'm going to mainly talk about 3 parts. One is flower inducing technology. The second is marker assisted selection. The third part will be the multiple environment test result. So at CIAT, we use progenitors to test the effect of the red light, or it's also called photoperiod extension. So here it showed the progenitor with less than 4 branches under the natural light. You can see compare with the natural light or a dark night. So the photoperiod extension or red light, it the progenitor require less days to have the first branches. That means that in general we think that's the possibility to have flower. And if we look at the detail of different clones, so again we compare the photoperiod extension, the orange dot, and also the natural light, the blue dot. And you can see in general most of the progenitors have good response to red light. Under red light, it requires fewer days. You can see compare with natural light, more than 120 days. But under red light, in general, the days required for the first branch is much less. Okay, so and the second part I want to talk about the CMD markers. So first we validated the markers using the population in Southeast Asia. So one is the germplasm we collected from Vietnam in farmers field. Another population is introduced from CIAT as 102 clones. So that's mainly from several fossil families. Okay, so we tested the population in different environment, and you can see in general we have pretty high heritability. And then we run the markers now. So here is the phenotype data, and we run the CMD2 links marker using the Intertech genotyping platform. And we compare the phenotype data and the genotype data, and we find in this CIAT 102 population is segregation population. Again, with several fossil families, we can see the clones with resistant alleles T and A. In general, it showed a very low CMD score. However, for the diversity population, the resistant allele T and A, the response is not that dramatic. So at least there's no very low CMD score close to 1, or very close to 1. So we conclude that this CMD linked marker work very well for the segregation population, but not for diversity population. So in breeding practice, once we know the genotype of the both parents, we should be able to use this marker and to make selections in early stage. And also in the Vietnam collections, the 142 clones or varieties, we identified 8 clones that showed tolerance to CMD. You can see compared with several checks, their CMD score is much lower. In general, it's less than 2. And if we look at the markers, the CMD2 linked markers, so the resistance does not match with the markers. So we are thinking this resistance might be some new resistance. Now we are developing population to understand the genetics. Hopefully, this can be a plus of the resistance provided by CMD2. The next part I want to talk about the multiple environment test of the introduced material to Southeast Asia. So now we have trials harvested in 5 environments. So 2 trials harvested in 2020, 3 trials harvested in 2021. And we have 4 trials are still pending for harvesting. So here, first look at the heritability mainly show the quality of the trial management of the data collection. So we can see we have moderate to high heritability. The first part is CMD, it's high heritability and simple traits. And the second part is the plant type. And the third part is dry matter and yield. So based on this heritability, we can see the national program and also the CIAT team member in Southeast Asia really did a great job in managing the trial and also collecting the data. And we then look at the CMD pressure in different environments. So here on the X is showed 5 environment and Y is CMD score. And we evaluated the CMD in 4 different times: 1 month after planting, 3 months, 6 months, and 10 months. So we can see in this environment tanning in 2020, the CMD pressure is pretty high. Even in the first month after planting, the CMD score of the susceptible material is already a lot higher than 3. And in the next 2 is 2020 Dongnae and 2021 tanning, the CMD score is not as high as that. We call it moderate, especially in the early stage. It is not as that bad as the first ones. And then the last two ones we can see in the first 3 months, the CMD score is pretty low, even for the susceptible material. So we think these location might be low CMD pressure. All right, so this here I would like to highlight this 2020 tanning is very high CMD pressure. So we are going to talk about that later. Okay, so after we have the data from the 5 environments, so first we want to see the relationship among these 5 environments. So first let's look at the genetic correlation in CMD and plant type. We can see pretty high genetic correlation among the 5 environments. And in terms of starch and starch yield, for starch it's also high correlation, but for yield and starch yield, so we can see the 2020 tannin, it's a kind of special. It showed the lower correlation with the other environment. So again, as I mentioned before, so this environment have a very high CMD score, even start from the first month after planting. So this we are thinking this might be the major reason is cause this difference. And then now I summarize the performance of the best CMD resistant clones and also the checks. So you can see here the first one is K50, and then the next will be the next are the CMD resistant clones. You can see the CMD score is pretty low, and then the last 5, the last 4 is the local elite varieties. Their CMD score is pretty high. And here you also can see the plant type and the starch and the yield, dramatic starch yield. So all these clones were sorted based on the starch yield. So you can see K50, the CMD score is moderate, and but it still have a pretty good yield and starch yield. The next one will be TME 409. So this is the most popular variety in Africa. It also performed pretty well in Southeast Asia. The dramatic is slightly low. And another best material is CR24-16, good plant type without branching, and it has pretty good dry matter, and the start yield is also good. So for the others, the plant type might be not as good as the first 3. And if we look at it close, like at the CIAT clones, so the dry matter is might be cause problem, especially especially harvesting after rain. And for the local elite variety, under the CMD pressure, the yield and dry matter yield is in general is low. Okay, so here I show some detailed data. Again, so the multiple environment mean is in this column. This is for CMD, and multiple environment mean for starch yield in this column. And you can see the performance of the clones in different environment for starch yield and for CMD pressure, for CMD symptom. And again, you can see K50 in these 2 environments, the CMD score is pretty low. So we can see K50 have some tolerance among for CMD, and with lower moderate CMD pressure, the yield is still good. And again, it's quite clear that the elite local variety with in different environment, the performance is not as good and resistant material. So based on this data, we make a recommendation is that under low and moderate CMD pressure, K50 might still a good option, but the CMD resistant variety can provide stable dry matter and yield under low, high, moderate CMD pressure. And then the next I would like to talk about the future, what we're going to do. So the first thing I want to talk about the whiskbloom resistance. So we know K50 showed pretty good CMD tolerance, and farmers started plant K50, but K50 is susceptible to whiskbloom. So we already saw whiskbloom spread in farmer field. So now we are importing the crop collection from CIAT, and we are going to screen the crop collection in the field and also in greenhouse, try to identify the resistance to whiskbloom. Another thing we want to work with national program is to do genomics assistant breeding. So now in Southeast Asia, there is very limited effort or capacity using the genome-wide markers for breeding. So now at CIAT and also in IT, we have this expertise. So we are going to work with national program to implement the genomic assistant breeding. And we also think we should use the Southeast Asia breeding population to identify the markers linked with hydrogen matter is linked with erect plant type. So in terms of accuracies, we will have some training sections for field book, collecting data in the field, and using barcode printers. We already have a barcode printer in Vietnam office, and determine the TPE in the Southeast Asia region, and also develop the stage gate system for advanced breeding material or mix selection. And also, we think we should perform molecular marker-based quality control to make sure we have the correct material in the field. And I will stop here. Really, so this is comprehensive collaboration activities. Really appreciate the great effort from IT and from Hanlock Agricultural Research Center. And I would like to mention that Tu Wei, she is a major player in Southeast Asia, leading the activities and coordinate the activities with national programs. We have a new team member formed, so he just joined the Cassava program this year. We believe his joining will enhance our capacity, especially facilitate the CGIAR and NARS breeding network. Okay, that's all. Thank you very much.